Hello guys, how are you? I just wanted to make a short video explaining this topic because I think that is easier to um, to explain if we record a video, and also it's easier to understand if we record a video. So the first of all, the correlation coefficient is represented by the letter R, and the easiest way to show the correlation coefficient or to explain this is with a chart that is represented with the y and the x-axis. And in this chart, we're going to plot some values. So plot some values that are the relation that the y-axis has with the x-axis. So what we have to say now before talking about the graph, we have to say that the correlation coefficient it does not imply causality. It only implies the linear correlation that a variable has to another. Is that it does not imply causality, and also it does not measure the degree of variability that one variable has to another. That would be the coefficient of determination, for example. So let's look at this graph, at this plot, and this join this point together with a line, right? So this line is draw connecting these directly proportional points, and it's looking up. So if the line is looking up, what we have to determine first is the sign. So the sign of this correlation coefficient will be positive because the line is looking up, and the number that came here is going to be determined depending on the amount of variability that the values has in the plot. In this graph, the values are not dispersed, actually are directly proportional. So let's say that the variability that they have is 1. Why is 1? Because the number that the correlation coefficient has is a number that goes from 0 to 1, depending on the amount of variability that the sample has. Let's say, for example, that we don't have this plot, but we have a plot with these values that are very dispersed in the data set. But if we look, we have a great amount of values in this part of the plot that is looking up. So if we determine a line here, it could be very likely that the line is looking up, right? But the values are very dispersed. What it means that the value of the correlation coefficient, it will be more close to 0 than to 1, right? So maybe here we have a correlation coefficient that could be 0.3, for example, and it'll be positive because the line is looking up. The line will be the correlation coefficient will be negative if the line is looking down, right? If the line is looking down, for example, in this plot, the line is looking down. Let's say that the values are looking down, right? But are a little dispersed in relation to the line. So maybe we can say that here is a correlation coefficient more close to 1, right? More close to 1. So it could be a 0.9, for example, 0.9. So let's look at this information. So the Pearson correlation is going to measure the linear correlation between two variables, but not the amount of variability that they have, because the amount of variability that they have is determined by the coefficient of determination. There is the correlation coefficient that is represented with the letter R elevated to the second potency, right? So here we can see a plot that is very interesting where there are not any correlation. As you can see, the values are everywhere. They are not directed to any direction. So if we draw a line in here, maybe that line is going to be in the middle, right? It's going to be in the middle. giving us a Pearson correlation coefficient of 0, right? Here the direction is going down, so the sign is going to be negative. Here the relation is going up, so the sign is going to be positive. And there is a lot of variability between the values that it would give us a number that is more close to 0 than to 1. I think that it's pretty clear. So let's open Stata, and we're going to determine the correlation coefficient of a data set. So as I don't have data sets prepared, I'm going to use the example data sets that are in Stata. So here you open sample data sets installed in Stata. We're going to use this one that is the life expectancy 2 that correlates the year and the life expectancy of well, let's look at the better at the plot. If we click here at the data set, sorry. If we click here, we're going to look the relation that the years has with the life expectancy. So if we look at this at the first value, we have that 120 years ago, the life expectancy was 47 years. But 80 years ago, the life expectancy was 62 years, and right now the life expectancy is like 73 or something. So we're going to plot this. First of all, we're going to determine the correlation coefficient of that data set that we just looked. As I don't have the commands, I don't have a lot of experience in Stata, but I think that using this this window is easier when you don't know the command. So if we open here the correlations, we have to write two variables. Let's do it again. Statistics, summaries, summary and descriptive statistics, and then correlation and covariances. So now we are going to select the two variables, the year and then the life expectancy. We click submit, and here we're going to have the Pearson correlation coefficient that, as we just thought, the correlation coefficient is going to be positive, and as it is most close to 1 because it's 0.85, as it is more close to 1, it would tell us that the values are not predispersed into the data set, right? So we can also click in options and display the means, and we can see the mean, the standard deviation, the minimum and the maximum value, just to do a more complete sample here. So let's do a graph, a scatter plot, basic scatter plot. We click in create, and this, in the scatter plot, we're going to use the y variable that we're going to use life expectancy, and an x variable that is going to be the years. Click in submit. And I wanted to do this because I want you to see how the values were plotted in this graph. And as you can see, there is, first of all, a positive correlation between the years and the life expectancy. That's the first thing. So or correlation coefficient will be positive, right? Will be positive. And if we draw a line in here, right? We're going to see that the values are not predispersed in the line because there are not values here, there are not values here, right? So there is not predispersed, so they're going to be very close to 1. And as we saw in the Stata calculation, there was a 0.85 the number of the correlation coefficient that is pretty close to 1. So that was just what I was trying to show in this video. In the next post, I will be talking about the coefficient of determination that is not the same as the correlation coefficient. And well, I hope that it was clear and that you have a nice weekend today. Yeah, this weekend. So bye.